Okay, good afternoon, everybody, and welcome to the fifth session of Sunoikis Digital Classics Summer Semester 2019. Today, we have a session entitled Programming for Humanists, and our guests are from the University of Florida, and they are Angelos, Barmpoutis, and Eleni, Bozia. I think you already know them because Angelos and Eleni have been contributing to Sunoikis Digital Classics since the beginning of this program, and we have been working a lot together. And also, they were in Leipzig last year, and they taught in our classes. And today they are teaching, I think, a cool topic, I have to say, because, yes, this is programming for humanists. And you have the description of the outline of this session on Hangout, a long, detailed description with readings and also with exercises. And the idea is a bit to experiment with natural languages in programming languages. So I'm summarizing a lot about this, but you have the description there, and we will also collect slides. But now, Angelos, Eleni, welcome back to Sunoikis Digital Classics, and I'm happy that today we have also two students from Leipzig in the call. And for other people on YouTube, of course, you can join the Hangout, or otherwise you can also ask questions in YouTube. But Eleni, Angelos, welcome back.
Hi, Monica. Thank you very much for the introduction, and thank you very much for having us here again. It's always a pleasure.
Thank you, Monica, and we should also welcome the students who join us live, and of course many others who will watch us later on YouTube. Now we will start sharing our screen to start the slideshow.
Okay.
Now, the topic, as Monica said, is programming for humanists, and it's a relatively new initiative that we started here at the University of Florida as a collaborative project that is led by the Online Learning Institute. What we try to do is to motivate students of different disciplines, and today we will focus for humanists, to learn coding. So, the questions that we will bring are the following.
Yes, I would like to also mention that I have been involved with this initiative because I have two different motivations. One is I would like to involve humanities students in programming, but I would like also to explore the structure of natural languages and the connection that it potentially could have with programming languages, in hopes that I can also motivate science students to be involved with humanities. So the questions that started us were, how can we integrate computer literacy into liberal arts curricula? How can we motivate students, like I said, of either side, even though today we are going to be focusing on humanities students, and scholars, researchers acquire coding skills? And what are the best practices for teaching computer programming to novices? But again, I would like to mention that when I say novices, I mean novices in both areas. How can we explore fundamental constructional similarities between natural languages and programming languages? And how can we, by exploring them, how can we find different ways to learn better both types of languages, without, of course, being reductive to the wealth of natural languages? One of the ways that I found that are most easily introduced into this kind of conversation is the fact that sustainability is always a major issue for funded projects. We mentioned here that 2/3 of NEH-funded digital humanities projects involve open source computer code, which would naturally mean that you would need some people who are, let's say, versed not only in the humanities, but also in programming, in order to be able to maintain them. However, I'm not talking about humanists doing everything. Digital humanities is, by definition, interdisciplinary and is supposed to be a collaborative product. But I strongly believe that if humanists have some ability in programming, first of all, they can enhance their own research questions. They can explore aspects of their traditional humanities questions that cannot be that cannot be posed by scientists. So if we have the tools ourselves, the basic understanding of programming, then we can also approach our traditional humanities fields in a more efficient way. Additionally, yes, we do need programmers when we are applying for digital humanities projects, but if we have some basic knowledge of programming skills, we can also keep maintaining these programs ourselves. And of course, we can also help the dialogue between the two disciplines. In other words, if we have some basic understanding of programming, we also know what the capabilities of programming tools are, which means that we can communicate them better to our computer programmers. Another issue that has come up through my work, both with students in teaching and in research, is that there are several open source APIs. For example, when you get an NIH-funded project, it is a requirement that it is going to be open source and open access. But how can we reuse and how can we actually use programs that other people and projects that other people have developed? In addition to the sustainability issue that I brought up before, there is the other issue, the other concern, the other problem, or the other possibility that we have so many projects that have been developed in the last 10 years or so, but how many people can they actually access them? How many people can they actually contribute to them? So are they really accessible to humanities scholars, to humanities students? So if, again, going back to our initial question and our initial motivation, if humanists are in a way self-sufficient up to a certain degree when it comes to basic programming skills, then not only can they develop their own things, not only can they enhance their own research, but they can also reuse projects that other people have used, thus not reinventing the wheel.
Now, this topic of motivating students and introducing coding to students of different disciplines is very well studied, surprisingly. You will find papers in literature from the 60s with many authors arguing that computer coding should not be a skill that only engineers and computer scientists should develop, but it's a very generic and applicable skill that all students of every discipline should actually be trained and acquire. One of the papers, specifically by Alan Perlis, argued that computer science should be part of a liberal education. Explicitly, he argued that all students should learn to program. And this, again, was a paper from 1960s. And back then, of course, I'm going back to the previous slide, the computer monitors were only typing characters. And this example here on the right-hand side shows that someone could draw, for instance, like an abstract composition, image composition over here with several letters, characters over here, making triangles, squares, that motivates that it is applicable to several areas, including graphic arts, for instance. Now, today, since the 60s, what has been done since then? One of actually, if you go online to different popular forums, like the Humanists, which is an online open forum, you will see that there are discussions about procedural languages, teaching coding in the humanities, and introducing coding to liberal arts curricula. One of the references that I will bring from 2005 is that it is mentioned that all students, engineering and liberal arts students alike, should have at least 2-semester computer science sequence in their freshman year, right in the beginning, basically, of their career, in order to understand what is their capabilities and subsequently apply those to their respective disciplines.
Of course, when we brought this up, when we started this project, about over a year ago, people, humanists particularly, were not very happy about all these statements. The fact that liberal arts students should learn programming language, why should they? Some also objected to that very statement, thinking that we are trying to substitute natural language with programming language, which is, let's say, to say the least, missing the point entirely.
So always when we start a new research area, there could be objections, but all of these publications, again from the 60s, but also they continue now, show that it's a very vivid topic. It's a discussion between indeed humanists and engineers, some of them agreeing, some of them disagreeing, but it's a very vivid discussion. To prove this point, there have been several initiatives towards that, several tools that have been created, and I will just show a few of them. Inform 7 is system design here for interactive fiction. So basically, someone can create a narrative, a fiction narrative, based on a natural language, but there are principles of programming where you can have your narrative and you can break it into different storylines, and connecting those little pieces as a toy in a graphical user interface over here exposes humanists while they are working on a written language in creating a narrative to use computer tools and again computer statements. So if the character does something, then this part of the story will continue, or if something else happens, then a different part of the story. So we have non-linear narrative. So Inform 7 is one of these approaches to use fiction again as a motivating element for liberal arts students to learn coding. Similarly, written language, in particular plays, were a motivating element to create a new programming language, a very limited, I would say, programming language called Shakespeare Programming Language, the SPL, which has their own, let's say, constructions, their own commands, but you can use them to actually write the entire script of, for instance, Romeo and Juliet over here, and this is an example of screenshot. Again, those projects try to bridge some of the fundamental principles of, again, humanities language, either in a fiction or a play, with some procedural list of instructions that we see in programming languages. Another one is, another project metaphor is visualizing stories as code. Basically, you can copy and paste a story, a narrative, in that interface, and this one breaks it down by doing some natural language processing and tries to create basically to convert all the verbs into some commands. So verb, we are instructing someone to take an action, or someone takes an action, does something. So this could be translated in programming languages as a command. Then there are nouns, for instance, the one who does the action. So that could be a variable that acts in a certain way. And so this tries to visualize stories as code, and again tries to bridge these two disciplines. Now, the big question, as Eleni said previously, how can we motivate the students and scholars of any discipline in the humanities? So and how can we apply some of these concepts that we saw in these previous projects to real programming languages? So beyond of these very limited interfaces that we discussed in those projects, what about, for instance, Python? It's a very popular language in the humanities. It is used a lot. R, JavaScript, other languages like real professional programming languages that could be used in practice in those digital humanities projects that Eleni mentioned. So that is the actual motivation for our project here.
I would also like to point out that when I work with my students, either humanities or science students may come in with some basic programming skills, or some of them with more advanced programming skills. Humanities students, not so often. However, what I wanted when we started with these projects is the same thing that I teach my students, my Latin and my ancient Greek students. I wanted them to learn how to learn. What I usually tell them is that if you learn how to learn a language, then you can learn any language. So going back to what I said before, my science students, my computer science students, may be familiar with a particular programming language. However, they still do not seem to have the flexibility to move from language to learn another language as easily. The humanities students, on the other hand, they consider programming language and natural language entirely different, which, yes, I admit they are, but they also cannot find the connections between the two. So what I want them to do is, through this new system that Angelos has developed, to learn, to be familiar with how to learn any programming language. So basically not to learn one language, but learn the fundamentals of a programming language.
Of course, the topic of computer education is a very well-studied topic outside of the humanities in general, as a computer education for all disciplines. And there have been several approaches. However, the main focus has been always on K through 12 education, expose basically students of younger ages to programming principles, so that later in college, for instance, independently of what is their career, it could be in the humanities, could be in liberal arts, they could have all these fundamental programming principles already built earlier in their education. So with focus of younger ages, there have been tangible user interfaces. And in the past few years, we have seen several of those in toy stores. You can go and see many of these puzzle-like interfaces that expose, again, very, very young children to those programming principles, a sequence of actions, how to put them together in a linear order so that they can achieve a particular goal. But of course, as you can see from the scope of these is to attract younger ages, so they are not applicable exactly for the particular audience that we're looking for. Later on, we have graphical user interfaces for slightly more mature kids, where we have a similar set of puzzle pieces, if you will, but they are all in a graphical user interface on your computer screen. You can put them together, and there are some incentives. For instance, you can make games, you can play sounds and all that. But again, because the focus is on younger ages, still this is not an appropriate tool to be used for humanities students, especially college-based students. Then there are text editing interfaces where they are very similar to professional code editing tools, where there is a main text area to type actually your script, type your code. But there are very specific, in those approaches, there are very specific applications. For instance, the one on the left-hand side can be used to create graphic art. So someone with interest in graphic art can use very simple commands and therefore learn programming that way to produce a tangible outcome, which is graphic art. On the right-hand side, there is a similar interface where you can use commands, again, in a text editor to produce sounds. For instance, play this bit for 15 times and this will make a song. So this introduces, again, students who are interested in audio remixing, for instance, to learn programming. But we see all of these different approaches like graphic art or sound remixing. So the question is there a similar creativity tool, a natural creativity tool for the humanities? I don't think that all, for instance, humanities students are interested in sound remixing or graphic design. But if there is, if we can find a natural creativity tool for humanities students, we can create something similar that focuses on humanities students.
So based on our experience in teaching mainly at this point, I believe that the so-called natural creativity tool for the humanities is language, regardless of whether we are talking about classics, where students actually have to learn ancient Greek and Latin, then we are, or let's say Spanish and Portuguese or other humanities disciplines, even when you are talking about the English department, for example, where students do not necessarily need to learn a foreign language. However, they are working closely with language. They are studying language through literature or linguistics, one way or another. So the most natural way to get them close to programming languages would be to teach programming language as a language. Again, I would like to stress that we are not trying to be reductive to natural languages. Obviously, when we are talking about any language, ancient or modern, we are mindful of all the complexities of the language, of nuances that the programming language does not have. However, when a student starts to learn a foreign language, again, ancient or modern, they are not familiar with those nuances. So how do you teach it to them? You start with the basics, or you start with teaching them the basic structure of the language. They learn grammar, they learn syntax, they learn how to put things in the correct order for them to make sense of a sentence. And I believe that if you take it down to the simplest form of language structure, that natural languages and programming languages can find some common points, that they actually do have some common points. And this brings me to the last point of this slide, humanities versus digital humanities. Again, I strongly believe personally that there shouldn't be a distinction between humanities and digital humanities. As there is no distinction between, let's say, medicine and digital medicine. When you are a doctor, and you are using modern tools, it is the same and should be the same when it comes to the humanities. We are talking about the same traditional humanities topics and the same research questions, the same, let's say, in classics, the same ancient authors, but we are approaching them through different methods and methodologies.
So now I would like to puzzle you a little bit. I will give you a short quiz. You might be familiar with some programming languages, and I give this very short script to several of the talks and the conference talks on this research line, and I ask the audience to just spend a minute and try to decipher this script here. And for those who are watching this YouTube video later, please do the same. I will just give you a few seconds, and please try and see, try to figure out what is the meaning behind this script.
Of course, if anyone who is watching would like to jump in, feel free.
I didn't want to pressure anybody to go public right now, but it would be great, yeah, if we had interactivity. But from my experience in conferences, many people from the audience feel confused, although they may be familiar with programming languages or other scripting forms. But when I reveal the answer to that, which is here, which is basically what you could type as a text message, just really quickly to reply to someone who tries, to sympathize or to support you, let's say emotionally, and say, well, don't be sad, or grumpy, be happy. So of course, immediately we will recognize this message. Now, what this proves is that what we use as a language to type something, especially now that we have typing interfaces in computers, in mobile devices, cell phones, tablets. What we type is could use some sort of scripting. For instance, the colon and the parentheses, or the closing parentheses and all that could be used as some sort of syntax, not the syntax that the natural language follows, but some sort of convention, computer convention that we have used. But we know that if we follow this as a command, so if we type this basically character first and that character after that, this gives an additional meaning to the computer, so that it is interpreted not as a set of characters, but as a nice icon. And of course, we have beautiful icons now in the modern phones, colorful and all that. But typing those through shortcuts creates a disparity, a difference between what we type and what we read. Now, this is not the first time that we do that. Those who used cell phones in the past decade may remember that typing a message in very limited keypads, like 4x3 numerical keypads, like the one in this Ericsson phone, required a repetitive, basically, use of some of the keys to compose some characters. For instance, there was a convention that H requires 2 times the button 4 to be pressed. Similarly, E requires 2 times the button 3 to be pressed. So now, although there was some sort of interactive assistance on the screen to guide us and help us with this type of composition, this is another example where we use some sort of script to type, but when we type and then complete that, there is an explanatory, actually, message, much more user-friendly, human-friendly, that appears, which is, of course, is the actual message that we want to write, the hello, in this particular case. So we have been used in that, and there is research that shows 1 billion people used this type of typing, learned how to program, let's say, language by using numbers to write text, and they had efficiency, significant efficiency that was 26 words per minute. So that was significant speed in typing. And I provide here a publication about that. Now, so there is an actual process, mental process, and here is why we have all these brain images, is that when you try to learn, and once you learn, basically you achieve this amazing speed in typing. And I give another example here of Morse code, where we have a similar kind of a system. There is a convention between alignment between symbols and letters. But once you start typing and learning Morse code, there is a neuroplasticity in your brain that indicates that this knowledge has actually accumulated in an actual form, that the declarative knowledge that you obtain has now become what we call procedural knowledge. So in other words, blindly, without even looking at the screen, you can just type and basically understand this, comprehend this, not as a sequence of symbols, but as the letters and the natural language that you are offering as you do this. So human brain does that, and this is part of the learning process, this neuroplasticity that is going on. And a much more recent study in 2013 from actually Transactions in Computer Education did the following experiment. Instead of using a programming language that borrows keywords from English, a natural language, such as if, else, for, while, and many others, instead of doing that, they replaced those with some arbitrary symbols from the hexadecimal system. For instance, instead of using the if command, you have to use B8. Instead of use the else command, you have to use 7F. And they tried as an experiment to teach that to new students, and they found that the difficulty is the same. So in other words, learning what to type, it doesn't matter if it is IF or B8, I'm going to learn it. And once I pass this learning curve, it has similar difficulty in both ways, then I acquire the actual programming skill. So, which is a very, very interesting observation that they did. So what this shows is that the language encoding involves two processes. First, it's a narrative skill, the typing, the writing, that I have the pencil and I actually use the pencil on the paper to form letters. Or in a computer setting, I have to type a particular command or to a sequence of keys on my keyboard to compose a word. And then there is the comprehension skill, where basically I observe what is the result of this generative action, and I can see that I actually wrote the word hello in here. So in other words, the generative skill could be anything. It could be inscribing, it could be typing, it could be encoding, but the comprehension skill is basically reading and understanding what is the result of that. And in those two parts of language encoding, there is symmetry. For instance, if I write on the piece of paper the letter omega in this case, then I read exactly what I typed, omega. So there is a symmetry. We expect to write exactly what we will read later. But this is exactly what we do in programming, and in most of the text editors, we type the sequence of characters, if, a, exclamation equals 0. And of course, later when we review that code, we expect to read exactly the same. That's exactly the identity between the generative and comprehension parts of the language. But all of these systems that we saw before suggest that we don't have symmetry. We can break the symmetry. So the generative skill doesn't have to be exactly what we need to read later. It could be something different because of limitations of the system, because of certain standards that we have set. The generative action could be a sequence of numbers that we type. Like I generate this sequence of code on my old cell phone, 4433 and etc. But later, when I read, right after I type this, when I read the message, I, of course, want to read hello, because that's exactly what I did. And similarly with the Morse code, and of course, with the emoticons that we saw previously, I type this, but I want to read something that is much more explanatory. Now, we also do that in many cases when we use shortcuts, because all of these are just shortcuts to some part of results. So when I try to close a window, either in Windows with Alt F4 or in Mac with Command W, I don't want to read that text, the Command W on my screen. I understand that this is what I typed, but I want to see the result of the action, the window that disappears in front of me. I don't want to see the Alt F4 written on my screen. Although I type it, I want to observe something that is much more self-explanatory, the result of this action. So what we propose after this theoretical background is, why don't we do the same to teach coding to humanities students? In other words, create a text editor that does not have a symmetry. And we use all these computer coding jargon and symbols as the shortcut to something that is much more explanatory. So for instance, if I type exclamation equals, well, that is the shortcut to is not or is not equal. So in other words, if someone generates this sequence if a exclamation equals 0, basically doesn't want to read that later. We want to comprehend and understand this code as if a is not 0, then do something. So this is the idea that we had to bring this symmetry, and of course, this has already been applied in a limited way in some of the professional text editors. For instance, this is the Google's Android Studio, where someone can type the lower part. So someone types, for instance, jump 545. The 5 and 45 here in the jump doesn't mean anything to me, but on the actual text editor that is shown on the top, there are some additive elements to what you typed. For instance, in front of 5, it says speed. In front of 45, it says decrease. That makes it much more explanatory. So in other words, although you typed something less explanatory on the bottom, in the actual text editor, they use this asymmetry, and they provide more user-friendly, human-friendly information to explain something like the numbers or later other commands. So having this as our general idea, can we replace every single token in computer programming language with something that is a natural language text or a phrase, or a word or a phrase, so that it is easier for us to understand? And of course, we can generalize this idea not only with text, but something with graphic, maybe for kids. So instead of the name of the variable can be seen as a name tag, because it's a name. So every variable that you introduce, every name, could be shown in a fun way to approach a particular age. In this case, maybe younger audiences. But for college-based students, let's say of humanities, we can use natural language in order to do this type of text replacement. So for instance, I want to type what is shown on the left-hand side, but possibly every token of that could be replaced from a word or a phrase in German. For instance, this was part of one experiment that, as Monica said earlier, I did last year in this class, in Monica's class, where the students observed these two different but identical pieces of code. One on the left-hand side in a conventional coding form, and the other one in this instantly mapped natural language code. And the question that was given to them is, which one you understand better? So the logic is the same logic, but in which of those instances of the same code you understand the logic? You comprehend basically this better. And the students spent some time with observing this and understanding the differences. And for someone who is, let's say, new in computer programming, obviously it is easier to borrow the knowledge, the existing knowledge that we have from human language, and read basically this as a text, as a natural language text, the one on the right-hand side, and it is very helpful to understand the logic because all the declarative knowledge is contained in here. So I don't need to remember the jargon plus equals. Instantly, I read that this is increases basically the value by a particular increment. I don't need to understand that the equal symbol is not the mathematical equal, but it's here, it's assignment. I'm instructing basically a variable to become, to take a particular value. Similarly, the var means that I declare a new variable, so I define something in here. And the outcome of this little study was that the majority of the students said yes. Above 80% said, yes, I understand the logic better when it is presented to me in a human language without using the computer jargon in there. Now, let's see this in action, and I will actually give you. I'm sorry. I will give you actually the real interface at this moment. If you give me just a moment to open a browser.
Yes, Angelos, take your time because we have time, and I'm happy to see the slide with the German translation.
It's easier for people to connect. Otherwise, we presented it about a month ago somewhere else, and people thought that it was just something that we are developing that they couldn't have access to. So we thought that today they can actually see that if they open it right now, they can actually practice right now. It is live.
Let me actually use. Hopefully, this will work over here. And hopefully the characters are large enough. So this text editor that uses this particular philosophy, I can type programming tokens, as I said, in JavaScript. So VAR, for instance, and in this case, I will use English replacement, not German ones. And maybe I could increase a little bit the font size so that they will appear better in YouTube here. So what I type one of the commands, which is var, to declare a variable. But the moment that I finished this, it was replaced with a self-explanatory word from English let. So I can continue typing, let's say, number. This is the name of the variable. Then the symbol equals, which, however, means assignment. So the moment that I finish this, and I will give, let's say, the number 2 over here, I complete this command, which is the correct, accurate command in JavaScript. But what I read is English, basically. Let number be 2. So this could be, for instance, age. Now, nothing is lost. So it's not like a new programming language. It's the real programming language. And I can go over here, and I can revisit what I typed. What is important is that by observing what the system generates, I can reveal some of my programming mistakes. For instance, let's say if age is 10, then this particular student, let's say, is eligible for something. So now, as this is in English, the corresponding symbol in programming to test equality is 2 equal signs. So instantly, when I type 2 equal signs, automatically is shown as is equal to. However, many students, many beginners, forget about the difference between 1 equal sign and 2 equal sign, and accidentally they type this. So they want to declare this equality test, but they type incorrectly 1 equal sign. And here we have some sort of incorrect English language, because this does not make any sense. It implies assignment, which is exactly the meaning of the single equal sign. So age B10, it implies assignment, not testing equality. So the student, by reading this and seeing that, okay, something is not right about that, can very often go back and say, okay, it's not right because I expected something else to appear. I expected to test equality. So as if you try to type an emoticon, and instead of typing closing parentheses, you type opening parentheses. You observe the emoticon and said, okay, no, that's not right. Let me go back, delete it, and type the correct sequence of symbols to find the correct emoticon that I wanted to type. Similarly here, all the tokens can be expressed like that, and I can say like a plus equals, which is another expression here, is being replaced by b increased by. Similarly, we have subtraction, and every single token can be seen in that way. Now, besides helping you to compose new code, there is a benefit of understanding someone else's code. So if I copy JavaScript from the instructors, let's say, example, and I paste it over here, I can read it exactly, and I understand what is the meaning behind that. And of course, gradually, because this is shortcuts, the plus equals, I learn it as a shortcut to the actual meaning, to the actual intention that the actual instruction that the program performs. I can easily make this connection in exactly the same way as we do it with emoticons, as we do it with shortcuts, with all these different ways. So in other words, we learn programming as shortcuts. Now, can we do that with other languages? You saw previously the German version, for instance. And I can simply choose the proper scheme, because this is nothing else but an alignment, a text alignment between the computer syntax and natural language syntax. And here we can see what this particular set of text replacement shows. Of course, the question is this the best possible text replacement that can be developed? Maybe you can have some improvements to suggest. Maybe you can make your own alignment that is better, with slightly better phrases, maybe with slightly better words. But now this, and I will let Eleni maybe elaborate on that, could find a use on what we said previously, when we start using languages like Latin, maybe ancient Greek, to create an interesting experience for the students of humanities.
So initially, as you can imagine, the idea that Angelos brought before as alignment is very exciting, but how confident are you that you can actually translate everything that a programming language needs, and terms, particularly technological terms, into something that doesn't exist anymore and hasn't evolved that way and towards these directions? However, as I thought that it would be easier for me and my students, because I worked collaboratively last year with some students that I had, students of Latin and students of ancient Greek, to translate these basic programming terms into these respective ancient languages. So even though initially I thought that it was an experiment, I wasn't sure whether it was going to work, I realized that even before we actually go to programming, even through our process of translating those terms into Latin and Greek, that students were actually getting some practice into moods, and they had to work with subjunctive, as you can see. They had to work with imperative. So even the very basic process of how do we find an alignment between a programming language, a programming command, and translate it into ancient Greek and Latin, helped the students not only do the basic translation, obviously, but also actually comprehend what is imperative. When we learn imperative in Greek and Latin, what does it actually mean? And it was easier for them to apply it into programming language and vice versa, because they had to actually realize what I command someone to do something, how it's going to apply in a modern context. So it was easier for them to do it, to understand programming in that respect, what the program was supposed to be doing. But it made them also think, actually, that's the word that I'm looking for. It makes them actually think and comprehend what subjunctive is. Because subjunctive is one of the, let's say, relatively more challenging moods that students have to familiarize themselves with, because it's not actually used in many modern languages. But through programming language, surprisingly, help them comprehend and practice the subjunctive. And I see that you are changing between languages. So we did that in Ancient Greek. Can you switch to Greek as well? We did that.
Modern Greek, Ancient Greek, and Ancient Greek.
We did that with Ancient Greek as well. I'm not going to lie, it was, yes, it was a very helpful experiment for the students and for me, but it also presented challenges. Challenge particularly, not so in modern languages, but in ancient languages when it comes to how heavily inflected the languages are. So we had to struggle, and this is something that my students here, our students here can help us with, but anybody who wants to collaborate with us, we invite them to contact us. So how close do we want the alignment to be? It is going at a point we need to make choices. We don't want it to be, obviously, we don't want it to be reductive to the natural language, but sometimes, like I said, the cases, it's very hard to make them match. We want to be, to stay as close as possible, obviously, to the programming language, since this is what they are going to learn, but also to the vocabulary and the purity of the vocabulary of the language of origin, Ancient Greek and Latin in this case as well. But I believe that at least this first phase of translation of the commands has worked very well, and it was not to the disadvantage of either the language of origin, the natural language of origin, or the target language that was JavaScript.
What is interesting is some students could get some help on, even they learn, for instance, Ancient Greek in this particular case, we still have the English translation in here. So there is an alignment through the programming language between the corresponding translations of the language that we have here in this system. So someone could revisit the English version here and understand what is going on. So what is the meaning between of this command, or the double ampersand, for instance, over here, which means and then revisit the previous version and understand what is the alignment of the corresponding text replacements in here.
And here it's a very good example of syntax as well. So it's not only a matter of vocabulary and of, let's say, verb moods, but also the use of dative here. So I didn't want just me to do this data translation. I wanted to work with students so that they can actually see that one language is not that far from the other. Obviously, like I said before, when a natural language leads to works of literature, and this is not what we are doing here. We are not saying that if you do this, then it's equal to reading Aeschylus, for example, or reading Virgil. But the basic process of learning the basic structure of the language remains the same.
And of course, there are questions such as, can we have an alignment, a perfect straight alignment between programming languages and all languages? In some cases, we cannot have it for every single token. Some tokens can be interpreted and aligned better than others, and several languages, due to syntactical and grammatical constraints, have some limitations. For instance, in this particular case, in Turkish, we couldn't find a proper translation that maintains straight alignment in here. Therefore, we maintain some of the jargon, for instance, of the original code. And as you read, for instance, the German one, you may suggest some better translation, better alignment in this case. So it's an ongoing process that we hope that many people will get excited and participate, so that we can include more languages.
We also had an issue with the position, the genitive in Greek, the way that it was going to go, let's say, the sentence, the word order in ancient Greek versus the word order in the way in JavaScript.
That's a very good observation. So let me write a new example. In object-oriented programming, for instance, when I create, I don't know, let's say, an actor is let's say, a new person. Now, in object-oriented programming, there is a command that I can give something, a property, to this object. For instance, using the jargon dot. So, for instance, this is let's say the order of this actor, I don't know, of appearance is whatever one, or something like that. Now that dot, because it's a property, the order is a property of the actor, was interpreted here as apostrophe S. So it's actor's order B1, or it could be a prop. It could be something else, another property. It could be actors, I don't know, dress to be the black. So it's a property basically. In all of these cases, the dot was interpreted as apostrophe S. But in object-oriented programming, the same symbol could be used as instructing the actor to do something. For instance, say, so the actor says this. Now, because we wanted to have the best possible alignment, the same symbol here was replaced in a completely different way with here the word do or the word apostrophe based on context. So if it is followed by a word and parenthesis, so in other words, this is the syntax for executing a method of the particular object, this is interpreted as actor do this, do say welcome, or do appear on the stage, or do move, do hold the prop, or something like that. I can do the same hold, let's say, and I can have something prop. If that was a different object. Now, if we try to translate that to ancient Greek, as Eleni said, we have some interesting observations. Now, the article here, it should be that refers basically to the actor. So in other words, the actor's order in the actual alignment should be the order of the actor. So the word to works mostly as of rather than apostrophe S in English. Therefore, if we wanted to maintain a straight alignment between computer code and ancient Greek in this particular case, we had to reverse the order of this word, as we cannot put it in front of that if we wanted to maintain truly a straight alignment so that we can teach the programming syntax in this case, which is the objective. Therefore, since we don't have a perfect straight alignment, we had to fabricate a new syntax or a new element here that indicates that technically to here of refers actor. So in other words, of actor, the order, which of course is the order of actor. Yeah, but you see, there were syntactical limitations in this particular case that made us realize that we cannot achieve the perfect alignment between, in that case, between between computer code and the corresponding phrase in natural language, and we had somehow to indicate this.
But even though we had to make choices and we experimented with a couple of different, like I said, we worked with our students, we got their feedback, and this is where we landed for the moment. It doesn't mean that we cannot change it or we will not change it. However, I still don't think that these kind of limitations should be prohibitive as to not to let students learn programming this way, or familiarize themselves, students who are familiar with programming, familiarize themselves with the natural languages because of that. It's, again, in my opinion and from my personal experience in learning ancient and modern foreign languages in general, when we are learning a new language, we translate it into usually our mother tongue. That doesn't mean that we always have the same alignment. It's the same when you are, for example, my native language is Greek, when I was learning English, but when you are learning English, it's a very different word order and alignment from when you are learning German. So even though, again, the programming language only gives us the very basic of what a natural language has to offer, it doesn't mean that we cannot learn one through the other. regardless of which language is the one and which you consider the other, if you are a humanities student or a computer science student. But again, it's the same alignment or lack of alignment, the same issues that we have with word order when we are learning another foreign language. But we do find a way to translate, we do find a way to make our own mental connections between different languages, and we transfer these connections and we make them every time we translate from one language to the other. And it's the same, actually, the same issues that we have, and we don't have to go far, when we are learning ancient Greek and Latin, we translate them into modern languages. They are, like I said, they are heavily inflected languages. They have nuances and constructions that do not survive any longer. Perhaps ancient Greek have more connections with modern Greek, and similarly Italian with Latin. But beyond that, most people around the world, as I hope that they are learning ancient Greek and Latin, they are not as likely to make these kind of connections. But they do find a way to make some sort of more creative alignment with their own language of origin.
And the actual question is, okay, if we have this as a tool, as an interesting tool, as a playful tool that could motivate some students, what would be good exercises for you that are watching this video, but also for the students, if you want to apply this to your own classroom, what would be good exercises for them so that they can build this connection between again, humanities and learn code at the same time. And we present here just a few examples to give you ideas that you could borrow and implement in other cases. One of the examples is use of theatrical plays to somehow transcribe them in the form of a code. As I explained earlier, theatrical plays, the scripts are very similar to computer programming because it's a linear order of instructions that we give to actors to enter the stage or to give a prop, to say something. And this is a very brief example of the beginning of the first act of Romeo and Juliet by Shakespeare. It was typed exactly as you saw before in the same interactive interface. So what I really typed was this, and you can see that I use object-oriented programming with this dot jargon that we discussed previously. But when we read what we actually typed here in this English version of the code, it can be actually read as a full text, as an actual script of Romeo and Juliet, where we have two characters, Samson and Gregory here, and they have some properties, they have some props. So the one is holding a sword, the other one sword and buckle, and at some point they enter the stage. So this is basically performing an action. So Samson and Gregory perform an actual action. They enter the stage, and then each of them say, so this is the exact order of Romeo and Juliet. So Samson first says, and this is the exact phrase, and Gregory says something else. And of course, we can continue doing that for a longer script or for multiple different scripts. And another example in Latin in this particular case is transcribing what can be found, information that can be found from Pope Gregory's epistles that have to do with the introduction of the Gregorian calendar, and calculating the discrepancy between the Gregorian and the Julian calendar. Now, there are several numbers here that correspond to actual dates. So starting basically from the date 325, where the first Council of Nicaea was held. So starting from that particular time, we want to go up to 1582, where the Gregorian calendar was adopted. So we have to perform an iteration up to that point, from 325 to 1582. And according to the astronomers, they calculated that the error in this particular case was that many days every year. So we are missing a small amount of time every year. But of course, more than 1,000 years later, of course, this was accumulated to a significant discrepancy in dates between the Gregorian and Julian calendar, and of course that motivated the use of the Gregorian calendar. But coding this, so basically taking the information from a Latin document from Pope Gregory and doing this very little exercise, how can I transcribe this? But transcribing it using JavaScript. So the actual code here that I typed is this, so plus equals and the syntax with the brackets and all that. But reading it back in Latin, very close to the original form of this, of the source of this information, creates an interesting tool for students and for instructors also to introduce coding to humanities curricula using examples like this.
And we've also explored other possibilities, what kind of texts would be easier to use in order to do these kind of exercises. We thought, like Angelos said, that theatrical plays will be easier since we have more often than not, there are places where we have fast exchange of dialogue, so we can introduce new characters, which fits better, I would say, with object-oriented programming. Additionally, places where you actually have, let's say, commands, do something, say this, or where there are objects like props that are introduced. So two of the plays that we have been working with is Aeschylus' Agamemnon, the particular exchange between the place where Clytemnestra wants to have Agamemnon walk on the red carpet. And in Latin, we have been working with Plautus Rudens, where they have the exchange about the trunk of objects and the objects that are found within, and they need to be identified.
And indeed, transcribing this reminds us into programming. Basically, we have characters that alternate, so with very short phrases that we can copy, similar to the example that we presented in from Romeo and Juliet. And of course, if they have some actual tangible result, they enter the exit from the stage, they exchange objects, and this is a very good example that could be used again as one of the exercises for this week's discussion. Then, of course, we have what is the common between all that is that the use of natural language is what we try to find here, to show that this is the connecting element between not only classical studies but also other humanities disciplines, because natural language is the tool for critical thinking that is used in anthropology, in English, in other humanities disciplines. So natural language is the common element. Therefore, it could be seen as the creativity tool for the humanities, and having a flexible tool like this one in the classroom, bringing it into the classroom, could facilitate this fitting into humanities curricula. And the challenge now is basically to be able to first create a proper alignment. We already made several here, but improving them also is a possibility. If you suggest something for a different audience, if someone is more mature, maybe could use a different wording in some of these alignments. And also the second step is finding meaningful exercises that are useful, easy, first of all, and close to the humanities, again, curricula, so that they can actually be presented to the students, non-engineering students, and with the conjunction, with the use of this particular tool, they could acquire this coding knowledge. Of course, they can transfer that knowledge after that into real use of coding, more professional use of coding, by utilizing some of the APIs that many humanities projects have created, and going over there and understanding easier now what is the syntax and what is how they can use those in real research.
So far, what I've seen is my observations from my students are two. One is that as soon as they get familiar with this kind of programming, they prefer to find their own work of literature, their own piece of work that they want to work with. It makes it more interesting for them, or it makes it easier for them, perhaps, working with a text that they are already familiar with. The second is that regardless of whether they are going to continue working with that particular programming interface, they do so more familiarity and some easiness towards programming languages after having come in contact with this kind of programming interface, or this sort of introduction to programming.
And several of the questions that we asked during this presentation, and some of them are also being covered a little bit in the reading that we associated with this particular presentation, are the following. So, what are the grammatical and syntactical problems in this alignment? Is the straight alignment possible, and what languages are better for having this straight alignment? Nouns, it's something that we did not discuss. The nouns are the little names that the user introduces, and because you type them and they appear as they are, and you can type whatever you want, there's no actual translation taking place in there. So if I type actor, it appears as actor. It will not be translated into ancient Greek or Latin. And in many cases, this is shown as some sort of strange mix between ancient Greek, that you see all the commands, and the English or Latin-based names of variables that the user has introduced. Therefore, can we do some sort of noun declension, noun translation in there? Although it's not a limited set of commands, the user has the flexibility to type anything they want as a noun, as a name of a variable. And all of the examples, this tool so far has been demonstrated in JavaScript. It's a very generic programming language that follows the standard syntax convention that you see in C++, C, Java, and other modern programming languages. But it has not directly been applied to those other languages. So the question is, can we find an alignment or extend this alignment so that it can be used beyond JavaScript? For instance, Python, R, other languages, popular languages, and this is an interesting exercise also for you to think about. At this point, we would like to thank you for watching this video, and for those who attended live, thank you for your participation. And we are open, as Eleni said, to collaborations. We feel that this is an interesting project that could bring tangible results in classrooms and help students everywhere in the world. And we'll be happy to collaborate with you in creating new exercises that could be adopted to your curricula, but also using introducing new text alignments to a different language. So if you find that your natural language is not part of the list here, please reach out to us, and we'll be happy to assist you how to create an alignment to a different language here. And we would like to extend this for the public use. It's an open access. It's available online, and we will be happy to collaborate in any way we can.
I would like also to thank you for your time, for your attention, and if you have any questions, either now or later on, don't hesitate to contact us. Thank you. So we switch.
Okay, so Angelos, Eleni, thank you very much. It was great. And I don't know if we have questions. So we have a long comment in the chat by Anise from Brazil about... Yes, I think you can see I hope you can see the chat. So
yes, I'm reading it right now.
So yes, we can also use the chat for questions. We can't see the chat in YouTube because it's only on Google Hangout. But maybe we can comment.
I think she made a very good point that, and I will read from here, like a barrier for humanist engagement is that to obtain some code that is good and interesting enough for a project in humanities. So along these lines, we mentioned like theatrical plays. That possibly, then maybe that would be the next phase of this project, to create exercises or curriculum, basically guidelines with some of these samples that Anissa mentions, having, for instance, transcribed a piece of code that aligns to an ancient Greek theatrical play, a Latin theatrical play, maybe an English one to be more broad, Shakespeare's play. But also other examples. I found the one from Pope Gregory's letter very interesting, because again it combines some maybe like a numerical and tangible application of what was included in that letter, and justifies and explains a little bit the history behind Julian and Gregorian calendar in an interesting way that could be turned into a small coding project, which includes like 5-10 lines of computer code. So creating more of these examples and having them available online as a small curriculum, I think this will help some of these comments that Anissa made.
But again, even though, yes, I agree, when they start, they need guidance as to, okay, I learned this, so how do I use it, what do I do with it? Once they get a little bit more familiar, you usually get the question, so do I have to do this exercise? So once they are more familiar with the interface, then, which is, for me, it's always very encouraging, which means that they are already familiar with both the interface and the basic programming, and they are actually eager to try it on something that they like, which goes back to our basic principle when we started this project, that you can find the connection between programming and natural language, between programming language and works of literature. That's why they feel that they can go back and start working on one of the texts that they were going to work on, and they actually want to see whether it's going to work with the programming language as well.
And the use, if I want just to say, I see we have two more minutes. Many humanities scholars who are into digital humanities and already know coding had suggested to us, why don't the students use available videos online, lynda.com. There are coding lessons online. But the problem that we try to address is not the lack of textbooks or literature for learning coding, but giving a video, an instructional video for computer coding to a humanist. It's like, okay, why don't you learn nuclear physics? Okay, it's irrelevant. I don't see the point why to do that. And of course, I don't understand it. Even if it is explained in a small language, I don't have the motivation. And I don't feel engaged to that particular topic. So what we try to do here is not to address the lack of material. There is tons of material online, but we want to address the lack of motivation. We bring the motivation as the language. Language is the motivation. Use ancient Greek and try, can you code in ancient Greek? Okay, and at the same time, learn a professional programming language. So the motivation here is what we try to target.
I think this point is important because motivation, of course, and I think, at least for my experience, also a sort of exercise is in the end that you said these experiments are a sort of bridge between liberal arts and computer science, and they are also to help humanists to learn coding. But in general, I think that this effort to understand a script, to understand commands, is important also for computer scientists, because my impression is that sometimes when you learn a programming language, then in the end, you know commands by heart. But if you think, while, if, else, what do they mean? Of course, here we can see the power of English, because this is the thing, that the programming languages were born in English, and you can see how the English language is powerful. But understanding really what they mean. And of course, this is a question, usually this is a question for humanists, in the sense that when humanists start coding, they immediately say, what does this mean? What while means? What if, the command if else means? I think this is a very a question from humanists, but I think that motivation, and in general, not only for in some way helping humanists to learn, of course, this is excellent for humanists who have difficulties at the beginning to learn programming languages, but in general, also for computer scientists, I think. So that's why this exercise, I think they are really fascinating. And I have to say one thing about the example with Shakespeare and then with Aeschylus. Well, this is a philological note. I think that adding these instructions for reading these plays is something like adding notes, like scholia, you know. For me, I am a philologist, so I think it's wonderful, because these commands, they add instructions for reading the play. The play beyond programming languages, beyond telling something to the machine. So really, it's great, I think, and I think this is a new example, because last year I didn't remember this, but I think it's wonderful.
We have been working with different kinds of examples and different kinds of texts, because initially this started with us when I said to Angelos that I want to work with this and collaborate on this. He gave me the list of commands that needed to be translated. So one of the first was translate in ancient Greek, let Bob be a new robot. I said, okay, now you are kidding me. What do you want me to translate a robot into? Which you can, which is another set of a whole other discussion. But when you start getting into this, you can, like you said, notes as in scholia. So you find so many, humanists can find so many connections. It's but going back to your computer scientists, last time that I taught this class, not only with the programming, my digital humanities class, 90% of the students were from the computer science department. I always had students from sciences, but this time was the highest concentration ever, 90% of the class. And what I want to, besides the connection with the humanities, creative thinking, writing, etc., but like I said at the beginning, how to teach them to learn how to learn, basically. Because like you said, they know a programming language, but they don't really comprehend what it is that they are programming. So if they learn the very basics, then they can actually apply it, even computer scientists, and go on to other languages as well. And the same goes for humanists.
Yes, also because as far as I know, we are, well, of course we have many programmers, but the risk is to lose people with the real comprehension and understanding and ability to program. This is a problem that we have today. So I think that going back to this, really understanding these commands, and then you can use any programming language you want, because the risk is that you learn a specific programming language, of course with a specific syntax, but if you don't have an understanding in general of programming languages, this can be problematic. So yes, no, so thank you, because it was great. And I have another question. So this project, Emoticoding, is meant to be, as far as I understand, a crowdsourcing project, in the sense that you want to involve people for adding languages. And I see that you can save, basically, so you have to log in, but first of all, people and students should get in touch with you, if I understand, as if they want to contribute to it, and then they can add alignments.
First of all, the editor on its own, you can use it if you don't need to save. For instance, today I didn't save anything, so I didn't log in. If you want to create a script for you that you want to save, of course, there is the standard Google and Facebook login. You can instantly do that. You don't need to contact us for that. But if you want to change the tool, so contribute in changing and improving the tool, yes, please feel free to contact us. we don't have an editor of the tool itself online. And we will be happy to give you access to the backend, let's say, of this, and give you a list, for instance, of the tokens that could be translated to another language, and this will assist us in creating, supporting a new language, for instance, or a new alignment through that system.
But the tool itself, they can go ahead and use it right now and try the exercises that we have in the module on GitHub and play with it, create something useful and save it or not. So this is available, this is open, and they don't need to contact anybody.
Okay, now this is important. I'm asking also because, of course, you can't have millions of people contacting you, but I see, so the tool is available, is online, and if you save your work, other users can see your data?
Unless you share it. It's the sharing is works like YouTube. You can upload a video, but there is a very unique link with alphanumeric that corresponds to the particular script. If you want to share that with someone else, that is fine, but it's very hard for someone without knowing the link to find your code. So technically, yes, it is open access. It can be found, but you have to share it.
Okay, so I'm asking this because I remember the tool, I know the tool, but I was asking this because we have students and other people following us. So just for general audience to know that you can use this tool, you can experiment with it, and you can save your data for working again. And so please try to use it, because this is also a great exercise in general for learning translations and alignments. Okay, so now I don't know if we have other questions. We have students in our Hangout. I understand that so the presentation was great, but also we have many things. Of course, I always encourage students to ask questions in the Hangout, but I can understand that maybe, and this is, there are new students also, maybe this is the first time they join our Hangout, and it can be not easy to ask questions immediately. Anyway, you have, and now is 6:22 in Leipzig, in Germany, European time, and our time is almost over, but you have, as I said before, in GitHub, you have the session outline with a description of this session. You also have links to readings and by Angelos and also other contributors, as I see. So you can have a description of this method, and then you have definitely to try to use emoticoding to see how it works. And there is also, sorry, I'm reading the page. You also have exercises, and so you can try it. This is important also, especially for the students in Leipzig, if they want to try this and to experiment with it. Okay, so if we don't have other questions, and I see in the chat that, of course, we want Portuguese. We have a strong community in Brazil, so definitely I hope we will be able to have also Portuguese.
That would be an interesting student project. So if Anissa has any student who would like to translate, it's 80 phrases, I think, 80 words or phrases that need to be translated from computer code to programming language. We can give you that list, and someone can just simply type what they feel it's the most appropriate alignment and translation in Portuguese, and we can do it. It's I think one-day job.
It usually takes between 40 minutes, and it's 40 minutes and an hour and a half, depending on the language. The Latin and ancient Greek lean towards the hour and a half. The modern languages were closer to 40 minutes to translate the tokens.
Okay, so we have an assignment for our community in Araraquara, and I know that they are very active because we already have translations into Portuguese for tree banking, for our tree banking guidelines. We have also students in Araraquara adding subtitles in Portuguese for our English sessions of Sunoikis Digital Classics. So I'm not asking Anisa to work on this, but I'm sure that at some point we will have something from Brazil. And I also
she does say, and we have someone else who's saying that she's going to translate in Russian, and Anisa says that she's going to find a student. So maybe the next Sunoukises can be with these translations and exercises in these languages.
Okay, this is excellent. I have a student here, yes, in Leipzig, and she can translate into Russian. Well, of course, that can be a good exercise. Also, a few lines of code, and then you will see that you need some time. But I remember last year in the class working with the German students. It was really interesting because I remember that we started discussing because, of course, different people were suggesting different translations, which is another interesting thing. Again, this is a philological thing, of course.
Yes, exactly.
So aligning different translations is really super interesting.
We had the same thing, now that you mentioned the different translations, we had the same questions regarding subjunctive and imperative.
Yes.
So what makes more sense? So then you really have to get into a thorough understanding of the programming language and what it is that it is actually saying in order to use either subjunctive or imperative.
Yes.
So you really get into the nature of both of the natural language and the programming language in order, if you want to do it, to stay close and true to, both languages.
Yeah, this is super interesting. This difference between imperative and subjunctive. Of course, then do this. Okay. We want to be gentle with the machine, so not too imperative. But well, so thank you very much. So I would like to go on, but unfortunately our time is over, and I know that people are busy. And anyway, really, thank you very much. It was wonderful. And in any case, Eleni will join us again next week, if I'm not wrong.
Yes, next week.
Of course, and we will have Eleni again with us next Thursday with a session about stylometric analysis of Greek using vocabulary, grammar, and syntax. And so you have again the session on GitHub. So for now, okay, that's it. So thank you again, and have a good night, at least here in Leipzig, in the US and in Brazil. Well, have a good night. Yeah. Thank you. Okay, we have different time zones. So, okay, thank you again. See you next week.
Thank you.
Bye. Ciao.
Bye.